Assalamualaikum students. Students, you know I'm your teacher Zeenat. I'm starting the first chapter of O levels in IGCSE Chemistry. And this first chapter is, atomic structure. And now, you know that in atomic structure, we will talk about atom. Now, what is an atom? Atom is the smallest particle of any substance. We know that some substances are made up of molecules, some are ions, some are made up of atoms themselves. But at the back of the ions, at the back of the molecule, there are atoms. These atoms contain what? Electron, proton, and neutron. So the atoms that we can't even see with the naked eye, right? To identify atom, high resolution power microscopes are used. So we are not talking about them, but we know that atoms are smallest particles. We can't see them with the naked eye. But atoms contain electron, proton, and neutron. The atoms are divisible. The atoms contain the particles which are called subatomic particles. Like the electron, proton, and neutrons are called subatomic particles, which shows that atom is divisible, and atom is. Right? So to know about electron, proton, and neutron, how they are arranged, what are isotopes, what are ions, what is electronic arrangement, what can be deduced from the electronic arrangement. That is the shell, the electron in the outermost shell, the valence electron, and the group number, the period number, periodic table. To explain all these, I'm going to share my screen. When I'm sharing my screen, you guys are supposed to share, like, and subscribe my channel. So you guys do your own job right now, and I'm doing my own, right? I'm sharing the screen, and you guys are sharing and liking my channel. I hope you understand with me. This is notability. Atom. The chapter is what? Atomic structure and atom. Smallest particle of matter. Atom contain what? Subatomic particles. Proton, neutron, and electron, right? Now, structure of atom. You know, atom contain nucleus, and shells. You know, the central part is what? Nucleus. This is what? Nucleus contain proton and neutron, contain protons plus neutron. So they are called nucleons, right? They are called nucleons. So what are nucleons? Nucleons, the particles inside the nucleus. The particles inside the nucleus are proton and neutrons. They're called nucleons. Like atom contain proton, electron, neutron. Atom contain nucleus which contain nucleons. And these are shells. These shells, look, first shell, second shell, and third shell. These are called shells, right? In the first shell, 2 electrons can be accommodated, then 8 electrons, and then 8 electrons in your course. Like this is the debatable. That is the third contain 8 or 18 that I'm going to discuss. But if I tell you in short, in the first 18, right? It's what? 288 after 18. 2880. Look, in the first 18, it's 288. After 18, 2880. Right? There is a difference. This difference is 100% clear in A levels, but right now we are going to apply 288. Okay, like it works for your configuration. So what we are discussing, that atom contain proton, neutron, electrons. The proton neutrons are inside the nucleus. The electrons are in the shells. Right, now next thing. The electron proton, like you must know two things. What is the relative charge and relative mass of what? Relative charge and relative mass of electron, proton, and neutron. I'm making a table. This is now look. This is proton, neutron, and electron. Relative charge, relative mass. You know, the mass of a proton is equal to the mass of a neutron. Their masses are equal. They're not one. You know, the one means they are equal. Like whatever is the mass of the proton is equal to the mass of neutron. But you know, electron is 1840 times lighter. Electron is 1840 times lighter than a proton or neutron. So how you are supposed to write? 1 over 1840. Right? And what about relative charge? You know, the charge of the proton is +1. It's not actually +1. It's 1.6 into 10 power minus 19 coulomb. Plus for proton, minus this much coulomb. So whatever is the charge of the proton is equal to the charge of the electron. They are opposite but equal. So +1 -1 and no charge. So actually inside the atom, there are positive particles, there are negative particles, but is there any overall charge on the atom? No. Why? Because the electron and the proton are always equal in an atom. Right? Atom contain proton, atom contain electron. The proton is positive, the electron is negative, but there is no charge overall because the protons are equal to electrons. Right. Now, next, this is not in your course. You're not supposed to know this. And this is just for your information. Now, next. So our conclusion at this point is that atom is electrically neutral. Number of proton is equal to number of electron. Positive charge is equal to negative charge. The charges balance each other, are balanced. Charges are balanced. Now the question is, okay, we know that the protons are always equal to electron. But how to deduce about electron, proton, and neutron in an atom? Look, there are two numbers. This is the symbol of the element in the periodic table. Suppose X. My X is quite artificial. I'm writing it again. No, not this way. This is X. This is symbol of element. I'm checking. Wait, let me tell you one thing. This is symbol. You know, in the periodic table, there is a number. I'm showing it this way. There is a number here, and there is also a number here, right? This number is proton number. Proton number. Atomic number. Proton number, or I'm writing not good. This is what? Proton or atomic number. Number of protons in the nucleus of an atom. This is proton. This is what? Protons. Atomic number. And you know this is what? This is what? As I told you, this is mass or nucleon number. What is mass or nucleon number? Sum of proton and neutron in the nucleus of an atom. Now tell me, we know that protons are equal to what? Electrons. And we know that these are protons, so the same is the number of electron. And if I subtract this proton, I will get what? Neutron. For example, this is fluorine, 919. So 9 proton, 9 electron, 19 minus 9. 19 minus 9 is what? 10 neutron. Suppose sodium 1123. 11 proton, 11 electron, 23 minus 11, 12 neutron. Suppose phosphorus 1531. 15 proton, 15 proton, 15 electron, 31 minus 15, 16 neutron. For example, sulfur 1632, 16 proton, 16 electron, 32 minus 16 is what? 16 neutron. Now, if I now draw an atom for you, suppose I'm drawing this. Inside the nucleus. And then first shell and then second shell. I'm copying this so that I can use it again for another. Now look. There are 9 proton inside the nucleus, nucleon, 10 neutron. How the electrons are arranged. You know what is the rule for electronic configuration? There are some other thing also to be shared with you right now, right? So, like look, what is the rule? The rule is what? Rule of electronic configuration. What is the rule? First shell 2 electron, second shell 8 electron, then 8, and then so on. Right? Now, when my fluorine is having 9 proton and 10 neutron, the nucleon numbers, I'm left with how much electron, which I'm supposed to fill in? Out of 9. Out of 9, 2 are in the first. So if the 2 electrons are in the first shell, how much are left? 2, 3, 4, 5, 6, 7, 8, and 9. What is the capacity of the second shell? 8. So 2 electrons of the fluorine are in the first shell and 7 are in the second shell. So how many electrons in the outermost shell? 7 electrons in outermost shell. Means group number is 7. There are how many shells? 2 shells. Period number is 2. You know, first rule 288, second, electrons in outermost shell is actually the group number. The group number and number of shells is period number. Now you will be thinking that what are periods and what is the length? Wait a minute, I'm sharing the periodic table with you people so that then we can do the configuration. Hmm? These are your topical past papers. Look, atomic structure, IGCSE and O levels. These are available on my website, Chemistry by Zeenat. You can find all these topicals. This is periodic table. I'm copying so that I can share with you people. Okay. So what are we talking about? We are talking about the proton number, the atomic number, the nucleon number. This is the proton, this is the electron, and 19 minus 9 are neutron. Right now, look at the periodic table. This would be given to you in every paper, right? So this is a symbol. These are atomic number, the protons, and the relative mass, nucleon, they are almost the same thing, right? So this is what, if you see, there are 13 protons, sorry, 3 protons. Let me There are 3 proton, there are 3 electron, and 7 minus 3 is what? 4 neutron. There are 4 proton, there are 4 electron, 9 minus 4 are 5 neutron. 11 proton, 11 electron, 23 minus 11 are 12 neutron, right? So listen, these, like, you can do it for any element. Now next, this is periodic table. The basic information this periodic table is giving to you are the protons, the electrons, the neutrons, the symbol. These are all the elements, right? These are all the elements. Like you can see, there are some 116 elements right now that you can see. Next, these are called what? Vertical columns are called what? Groups, right? This is group 1. This is group 2. This is, sorry, group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Hydrogen is not in any group. These are transition elements. These are lanthanide, actinide. You have nothing to do with these, right? So this is what group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. These are transition elements. These are called what? Transition. Not with this pen. Transition, so huge. Wait. Transition elements, right? These horizontal rows are called what? Periods. This is what? Period 1, period 2, period 3, period 4, period 5, period 6, and period 7. And these are called group. Group 1, look, 1, group 2, group 3, group 4, 5, 6, 7, 8. So, vertical columns. Group horizontal rows. Period. Now, what I told you, that electron in the outermost shell is a group number. So in fluorine, there are 2 electrons in the first shell and 7 in the second shell, which is the last shell. So there are 2 shells, so the period number is 2. Look at fluorine. Is it fluorine in period 2? In fluorine, how many electrons are in the last shell? 7. So can we do this with each element right at its own place in periodic table? It will help you a lot. Look. So there are 3 protons. There are 3 protons. There are 3 electrons. 7 minus 3, 4 neutron. Now, if you see for lithium, these 4 protons, 3 electrons. These 3 electrons, how they could be arranged? 2 in the first shell and 1 in the last shell. So how many electrons in the outermost shell? 1. The group number is 1. There are 2 electrons. 2 shells. The period number is 2. Sodium, look at sodium. 11 proton, 11 electron, 23 minus 11, 12 neutron. Agree? The 11 electron, 2 in the first shell, 8 in the second shell, and 1 in the last shell. 2, 8, 1, 10, 11. So how many shells? 3 shells. The period number is 3. Look, the period number 1 is very small. This is period number 1. This is period number 2. This is period number 3. So there are how many shells? 3 shells. Period number 3. How many electrons in the last shell? Group 1. Look. 4 proton, 4 electron, and 5 neutron. 4 electron, 2 in the first, 2 in the last. How many shells? 2. Period number is 2. How many electron in the last shell? Group number is 2. Magnesium, 12 proton, 12 electron, 24 minus 12, 12 neutron. How the electrons are arranged? 2 in the first, 8 in the second, 2 in the last. So the group number is 2, but since 3 shells, period number is 3. See? Can we do it for phosphorus? 15 proton, 15 electron, 31 minus 15, 16 neutron. Yes. How you will do the arrangement? 2 in the first shell, 8 in the second shell, 5 in the last shell. So how many electrons in the last shell? 5. The group number is 5. How many shells are there? 3 shells. Period number is 3. Fluorine, 9 proton, 9 electron, 19 minus 9, 10 neutron. How the electrons are arranged? 2 in the first, 7 in the last. The group number is 7, 2 shells, the period number is 2. Right? In your course, the configuration up to first 20 are in your course. Like if I do it for calcium, how you will do? 20 proton, 20 electron, 40 minus 20, 20 neutron. 20 neutron, right? So 2 electron in the first shell, 8 in the second shell, 10, 8 in the third shell, and 2. How many electrons in the last shell? 2. Group number is 2. But how many shells? 4 shells. Period number is 4. How you will do it for aluminum? 13 proton, 13 electron, 27 minus 13, 14 neutron. Now, 2, 8, 3, 13. So how many electron in the last shell? 3. Group number is 3. How many number of shells? 3 shells. Period number is 3. I hope you understand. Now, suppose I am doing it again for aluminium. Suppose I am drawing it for you. Aluminium, 1327, 13 proton, 13 electron, and 27 minus 13, 14 neutron. The 13 proton and the 14 neutron are in the nucleus. They are in the nucleus, nucleon numbers. There's some. How the electrons are arranged? 2 electrons in the first shell, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now how much electrons are left? 3. 2, 2, 8, and how much are left? 3 out of 13. 13 electron. So 3 electron are in the last shell. So how many shells? 1 shell, 2 shell, 3 shells. 1 shell, 2 shell, 3 shell. The period number is 3. And the group number, how many electrons in the last shell? 3. Group number is also 3. The period number is 3. Number is 3. Now, after this, the next is what? Isotopes. You know what are isotopes? Atoms of the same element. Atoms of the same element. Yeah, atoms. You can just say atoms. Atoms with same number of protons and electrons, but different number of neutrons or atoms with same atomic number but different mass numbers, the nuclear numbers. Now, for example, magnesium 12, twelve, 24, 23, 24, 25. So what is your conclusion? They have same atomic number but different mass number. Why? Why their mass number differ? Because their neutron are actually different. How? 12 proton, 12 proton, 12 proton. 12 electron, 12 electron, 12 electron. But 23 minus 12. 23 minus 12. 11 neutron, 12 neutron, and 13 neutron. So what is different? What is different? The neutrons are different. The masses are different. You know, these isotopes, they have same identical chemical properties. Isotopes have identical chemical properties as the number of electrons and electronic configuration is same. Isotopes have same identical chemical properties as the electrons and their configuration is same. All these three, you have same electron, same electron, same electron. Their electrons are same, their electronic arrangement 2A2 are same, identical. But their physical properties are different. The densities are different, right? Their masses are different. Physical properties are different. For example, mass, density, different. Look, suppose this is hydrogen 1, hydrogen 1 to deuterium 1, 3, 1 proton, 1 proton, 1 proton, 1 electron, and 1 electron, 1 electron, 0 neutron. Oh, I made a mistake. No, it's perfect. 1 neutron. 3 minus 1, 2 neutron. See, what is different? The neutron. The neutrons are different. The rest are identical. Their chemical properties are same, identical, because the electrons are same. But their masses are different and densities are different. Physical properties will differ. Right? So I hope you understand up to this point. Now, we will do some past paper questions too, right? But first, after atom, ions. What are ions? I'm going to explain the ions in the next lecture. I think in this lecture it is sufficient, right? And I hope you understand. Till next lecture, what you're supposed to do, don't forget to like and subscribe my channel. Watch it again and again and repeat it. Watch it at your own speed, where you find easy. Go fast where you find difficult. You want to repeat it. See you. Allah Hafiz.